Paul here, and today on the bench we have a unique item. This is a vintage um, mustache curler. Didn't even know they made one. And the customer sent it in for repair. Um, he was afraid that this cord wouldn't last much longer. It looks like it might go out pretty soon, so he'd like a new cord on there. I think it was a wise decision. Um, Anyway, unfortunately, I couldn't find a cord this color, and I didn't think I could, but I was able to find a good one that I think will work fine. It's hunter green, close to the same hunter green, but not exact match. Um, I just think it would look better with a green cord than with a black cord. So I'm going to put this cord on here, and if the customer likes it, then we'll go with it. If not, I'll switch it with a black one, but rather than take time right now to worry about that decision, I'm going to put this new cord on here. It's one I had to order to get in, and in the picture, it is what it is. It's the closest I could find, and it'll look good. I think it'll look good. It's not exact match, but who's going to know? This color is, well, one, you don't even know what this color is anymore, and two, it's just not obtainable. So, and a black cord would just look, I was thinking of a black cord, but that just doesn't look good. I think this would look a lot better. It's a personal preference, right? But I'm going to go with it. So I'm going to take it apart and put this cord on, and we will get it back to the customer. It's really nice. Spring's got a lot of tension. It's in good shape. It's not bent. See, it's got some writing here. Like I can read that. I'm going to get my eyes on and a magnifying glass, and we'll see if we can read what this says. Okay. It says U.S. patent number 2094858, made in USA. I don't see any maker's mark on it, but it was patented. And so what I'm going to do is pull up the patent, and we'll find out what we can find out about this mustache curler. Very interesting. It's a little bit off center there. It's been used, obviously, and it's got a lot of age, so it bent a little, but it's still grabbing fine. Really nice. Okay, let me pull this patent number up, and we'll continue the video. Okay, I found the patent for this mustache curling iron. And the patent number is right there, 2094858. The patent was approved on October 5th, 1937. The patent was filed for on October 7th, 1935. So it took 2 years for the patent to be approved. During this time, between October 7th, 1935 and October 5th, 1937, it would have been patent pending. But since the patent number is on the device, it was made shortly after the patent was assigned. This was the patent date. Okay, it was invented or made by W.H. Stansberry. So he's the one who invented the process or the curling iron. And I guess this is a picture of a mustache. I'm not sure, but this is the half. I'll use my finger as a pointer so you can see. This is the half round cylinder, half a cylinder that cramps over the pin, which is the curling iron piece. The heating core is over here that heats this pin. And so it's not much different than traditional hair curling irons, right? but it's made for mustaches and a lot smaller. And apparently this is the original patent, so, and it's just for a curling iron is what it states, but it's definitely a mustache curling iron. So all curling irons that came after that are based on this patent, and he owned the patent, regardless of when, you know, the hair curling irons came out. He invented a curling iron, and this is his invention. And so it shows you the tip goes into the, here, it goes through the wood. This is the back of the wood. There's the heating element that's in the back of the iron back here, back in this part of the iron, and it heats up the rod, this rod that goes through it and comes into the handle. It heats up the rod, and he's the inventor, Warren M. Stansberry. And there's the attorneys that's he hired. He hired 2 attorneys to file for the patent. And there's the patent information, process of making a curling iron by Warren H. Stansberry, Grand Haven, Michigan, assigner to Peerless Novelty Company, Grand Haven, Michigan. So that's the company that actually made the mustache curling iron, was Peerless Novelty Company, and they were in Grand Haven, Michigan, a corporation of Michigan. So they were a corporation. The application was on October 7th, 1935, and that was the serial number that was assigned before the patent number was approved. And I knew it was old because it was 2,094. It had to be in the 30s, 20s or 30s because of the zero. If it was 21, 22, 23, it could have been anywhere in the 30s, but late 30s, even into the 40s. But when you see a low patent number, you know it's old. Anything under 3 million is antique. And so anyway, it tells you all of the process of building it here. And notes the figures as it goes through so you can compare the process with the figures. And he's the one who composed this for the United States Patent Office. So there you have it. There's the patent for that curling iron. And this curling iron was made in either 1937 or shortly thereafter. I don't know how long they made them, but they would have eventually put, once they sold a number of them, definitely put the company name on them. And this doesn't have the company name. It just has patent number, U.S. patent number, and made in USA. So this was early on in the process that they made this, which you can evidence by the cord, right? So we're going to disassemble it and put this new cord on it and go from there. So let me pause this until I get it disassembled, and then we will continue the video. Okay, I took the unit off of the heating element. This goes into the handle up to that notch there, right there. So you see if I lay that there, that's how far the heating element goes. It goes all the way to the end. This is the heating element. This whole part is what gets hot, this part here. This is an asbestos, most likely asbestos wrapper around where the cord connects. Now I can't do much with that because can't get asbestos. It has to be something that handles heat, and today finding something to wrap that in is not easy. So what I'm going to do, the cord is fine here. I'm going back here where it's connected to the heating element. I'm going to pull the cord through, and I'm going to cut the cord here where it's sort of deteriorated, solder the new cord on, and I'm going to put heat shrink that goes all the way up to here, because heat shrink will handle the heat and provide the insulation needed. And of course all this rotted green stuff will go away. It'll just be the new heat shrink, and I'll double up the heat shrink so it'll be well insulated and can take the heat, because there's no way to do what they did here. I might have to unwrap this and try to save it. And yes, I'm playing with asbestos with my fingers, but hey, that's how they did it when they made them, right? And you just got to use some precautions. I mean, you know, today we worry about the craziest things. I remember sitting on my dad's lap steering the car, 59 Cadillac when I was a kid that my dad had, and no seat belts, none of that. We didn't have all that craziness that we have today, but there were more cars on the road, I understand. Anyway, people, lived good long lives, and they worked in factories with this stuff every day. But still a little precaution is good. Wash your hands if you're dealing with it. And I'm not condoning you do that. That's up to you, but I don't have a problem with it. So anyway, I'm going to connect the new cord and solder it on, put the heat shrink in, and then I'll show you the finished cord before I reassemble it together. I'll be back. Okay, this is a cloth-covered copper wire. They wrapped cloth around the copper, which you see a little bit of the copper showing there in the middle, and then the insulation over it. So I figured for safety reasons, I'm going to leave this part of it intact, just because it's designed to handle more heat than a modern cord. And I'm going to connect the cord back here, away from the heating element, and put insulation down, and I'm going to do that for safety reasons to keep this from getting excessively hot and melting. We don't make anything as good as original today. In fact, this stuff is made in China. There's nowhere else you can get it. They don't make stuff in the United States anymore. So nothing I put on here is going to be as good as this original. And this is much more heat protective than that. So we're going to put the connection back here and keep that plastic in the handle where it'll stay cooler. And you can see, if I shine the light down through there, you can see down, can't get the light in there, you can see down in there and see it's just rough carved wood, and it really ain't much of anything. And where it slides in there, and then that side is just clean. Where the cord comes out, it'll be a nice tight fit. It had this restraining clip on it, this copper clip. Again, it handles heat, right? Copper is strong, and this is very thick grade copper. And that was pinched to keep the cord from going in. Well, unfortunately, it did slide in a little ways, so it was inside, hidden inside there. I don't know if I'll put that back on, or if I'll even need to, because this cord will be so much more, will be very tight in here. It's not going to like pull, but if I need to, I can put this in there. And it might be that I'll put it on this side here so that it locks in on the front end inside there. There's like a recess where it drops down inside. And so that might be where that was in there, like right there, so it couldn't come through. I'll probably figure that out and put it back the way it was that way. So anyway, that's step 2. Next is to put the wire on. Okay, I've got the heat shrink on up to there, the first layer of heat shrink, and I'm about to shrink that on that wire. Probably melt the plastic under it while I'm doing this, but so you can see what it looks like. The cloth is still in there. As you can see, the cloth is right underneath there. So that's shrunk on there now. And I'm going to cut these pieces of cloth on, solder the wires on with the new heat shrink that'll go all the way over these green ones and all the way up to that heating element there, and be in good shape. So that's the next point. Okay, I set the camera up where you can see what I'm doing. I got this over the other heat shrink, and when I shrink it, then this piece coming from the other side will fit over this one and overlap them. I'm going to go ahead and insert it because I'd rather it be in place and not have to deal with it later. Yeah, it is kind of a tight fit going through there. I want to mark this one then. Since this one is showing a metal clip that's going to be touching the metal case here, and this is a polarized plug, it's fine. I'm going to set this polarized plug for this wire, and that way this will not only be fine protecting it there, but it'll also be safe. If you grab this around water, you won't be worrying about a shock because the plug's polarized. So that's a good thing. It'll be an added plus. Let me go ahead and mark that one so we know which one it is. This one here. And that's going to be the negative, or the ground connection. I'm going to slide that in there, which will make a nice fit. Yeah. I don't want to push it in any further than that so I can see my mark. And that's it there. So this one, ouch, wire stuck me. Twist that up. This will be the hot, this will be the neutral. And I haven't checked this heating coil to see if it's good. I'm assuming it is, but let's go ahead and check it and make sure. Let me color that a little more so I don't, since it's the line move there. Let's go ahead and make sure that that heating element is not burnt out, because that would be a problem. So we'll check that now. Couldn't check it earlier because that cord was shorted for sure, and it would have just shown a short. Okay, so we'll connect this on there. And we've got 1K, 1,000 ohms. So yes, we have a heating element that seems to test fine. Not sure what it's supposed to be, but it's testing 1,000 ohms. Okay, clean this mess up a little. All right. Now, strip this. Now, normally, you can tell which one is the ground by these multiple lines in the side of the cord. See here, the side of the cord has multiple lines. This one's smooth, it has no ridges. They make that so you would know, right? You can check by looking at the cord. The side that has the ridges here goes to the thick plug. That's the ground side of the outlet. And if you want to be extra safe, you can find where the ridges are here on this end. Put a meter across from there to here. And you should have continuity. And we do. So that's the ground side, the ridge side. So, okay. Now here we want to put that with the one that I marked as black so that this is grounded in the outlet. It's actually grounded at your circuit panel. And we want to put the heat shrink. I cut a couple of these. Actually, I think, oh no, I only cut one because I used the other one. I'm going to cut one more of these. And we're going to put them over this. May not fit over that wire. That wire is pretty thick. Okay, let's use the white one. You don't really need much of this. Cut off some of the length of that, so it's not a problem. Okay, and that's just a little oil, grease there from the glue on the one I had to peel off. It won't hurt nothing. Okay, I do want to shrink these a little before we put them in there. So we'll go ahead and do that. So that they're nice and tight. Put them back in there. And there's our neutral here with the black mark. So we're going to put this over the neutral. And this one over the hot. Twist it up a little. And then we'll do the ground first. I'm going to wrap that on there. And we're going to put a little bit of flux so the solder sticks good. Excuse my hands and my reach. Perfect. Wrap this one together. Got a little bit of string on there. Let's see if we can get some of that out of there. It wouldn't hurt none, they just burn away, but better to be getting it out of the way. Yeah. What's that? Wrap that on there. A little bit of flux. A little lump there, we don't want that. Okay. That's out of that. Yeah. Let's cool that off. I misplaced my brush. Oh well. That's okay. Just don't want to burn my fingers. Okay. I'm going to smash that. With the pliers. Make sure we can get this on there. Cut a little bit of that off. Just a little. So that this will go over better. That's why I smash it with the pliers to get it flat as I can get it. So yeah, there we go. And we're going right up over the other one, the yellow one. Right there. Okay, and then we're going to do the same with this one. This one might line up a little better. No, it's got a little bit of a bend there. Let's take that off. Okay. So we got double insulation at this end here. Not that that is a big deal. As you can see, it's smaller around than this. It'll fit in the handle. You heat that up. And this is 350 degrees centigrade, this heating iron I got. So we're talking some heat. And this will be fine. Now, that's tight. I don't need that clip. You ain't gonna pull that through there. Yeah, yep, that's good. Perfect. Perfect fit. All right, now for the test. I don't have a mustache, so I can't curl my mustache, but we will check and see if this thing throws some heat. Well, first thing we'll do, plug it in my current limit in Variac, just in case there's a short. We want to know about it before we give it full power. So we'll bring it up to some voltage there. Okay, I'm at 70 volts, 68.3, and I'm drawing just 60 milliamps of current, or 4 watts. So that's fine. We'll bring it up some more. I'm at 106 volts. We're drawing 100 milliamps, or 10 watts. And that's pretty good. That's about as high as it should be. I would imagine at full voltage, let's see if I can put out that much wattage. 10 watts. It's up to 11 watts at 107 volts. And I already feel heat. Yeah, it's getting warm. Let's bring it up to 120. Okay, I'm at 121 volts. It's drawing 110 milliamps, which is 13.8 watts. Yep, it's getting hot. So 121 volts, which is today's mains. And let me set this in a safe place. How about there on that magnet? I'm going to disturb the camera for a second. Okay, there we go. We got 110 milliamps. I'm on the amp scale, so 0.11 amps at 121.1 volts, and it's drawing 13.6 watts, which is awesome. That's really efficient. Actually, what's the power factor? Power factor is 1. That is really good. So it works, and it's hot. All right, I'm going to go ahead and shut it off. And there we have it. I'll be right back. Okay, I went ahead and just clipped it in there. So it's clipped in just like it would be for a mustache. And we're at 118. I'm going to go ahead and turn the voltage back on. Bring it back up to around 120 volts. We're going to see how hot this thing gets. It does have a little bit of smell, and that's going to probably dissipate. I'll leave it on a little while, make sure. But that should just dissipate. Hasn't been used in probably, decades. I'm almost there. Okay, so we're at 120 volts, 119.6. And it's climbing. It's at 140 degrees, 143. Well, you can see what it's doing. I don't know where it's going to max at, and I don't know how this thing works. I mean, again, this is 1937, right? I don't know how they planned on limiting the current with this thing. It seems like it would get really hot after a while. I can't imagine them leaving it plugged in all of the time. And I wouldn't advise that anyway, because this is old. The heating element could just let go if it gets too hot. Like I said, it hasn't been used in decades, but it is working. It does have a new cord, and it is working. See, it's over 200 degrees. That's pretty dang hot. And it's still climbing. Let's see what the current is. 110 milliamps, and that's about right for 120 degrees. And you see it's still climbing. I suggest that if this was being used, you would heat it up, a couple minutes, and once it gets hot, I would unplug it. I'm not even going to let it go any more than that. I don't think we need it over 240 degrees. So I'm going to shut it off, and let's see how fast it comes down. still getting hot, but the power is off. So it should start dropping. Yeah, it's going to slowly come down. Okay, so we got it up to 250 degrees Fahrenheit. I think for this heating element, that's about as high as you want to go, or you're going to burn that heating element out. I would not leave this plugged in more than, say, a minute, and it should be sufficient. You know, there's no safety device. When it was new, the heating element was new. But now that that heating element is older and it's irreplaceable, I would not let it get more than 250 degrees. However long it took to get that high, I wouldn't leave it plugged in any longer than that at a max. Actually, I think a minute would be fine. You see how it holds its heat. It's been off a while and it's still at 200 degrees. So it holds its heat for quite a while. It's a matter of just heating it up and using it, not keeping it plugged in. Now, if you do and it burns out, I am not responsible. All I did was change a cord. I am responsible for the heating coil in this because it is, you know, it's almost 100 years old. But it handled it fine and it's cooling down. I'm going to let it cool down and it's ready to go back to the customer. Thanks for watching this video. If you found it interesting, learning about a mustache curler, I appreciate it if you give me a thumbs up. If you got any comments, record them below. And there you have it. We have a nice grounded, safely grounded. Of course, I wouldn't put it in water because water will go right inside there. Water will go right through there and short it out and be an electric hazard. So keep it away from water. The tab on here has some warnings on this cable, just on the cord itself, and it says the same thing. Do not use it near water. So keep this thing well dry, and it should be fine. You don't have to worry too much about touching this because it's grounded, but trust me, when that gets hot, you're not going to want to touch it anyway. That's why it's got a wood knob on there, so you don't have to touch it. Or plastic, I guess it's plastic. And some kind of Bakelite or something. I don't know what that is, but it's, yeah, it's not backlight. I forget what the name of that other plastic was that they had back then. It's not like plastic we have today. It's more of a composite. Anyway, there you go. Thanks for watching. Have a good day.